All right, so our goal today is to look at a review of the definition of the derivative. We are going to review the concept of the equation of the tangent line. We are also going to be reviewing AROC and IROC. So the directions might read, use the definition of the derivative to find f prime of x for f of x at x squared plus 2x plus 1, given the point -3, 4. So that point is the value at which we are looking to find my value or my derivative. And then we are using what we know about the definition of the derivative to simplify and solve. So definition of the derivative is the limit as h approaches 0 of f of x plus h minus f of x all over h. So we FOIL, distribute, the negative, look to clean this up algebraically. So 1 and -1 cancel, 2x and -2x cancel, x squared and -x squared cancel. Again, making sure you continue to write the limit as h approaches 0. I saw a couple times people put an equal sign between the limit and the function. It is the limit of the function. It is not the limit equal to that. Don't do that. You will lose points. Make sure you write the limit every line, or also you would lose points. The line above is equal to the line below. So if you're going to put an equal, it's either at the beginning of each row or at the very end of each row. So now I notice that I have an h in each part I can take out. Again, still equal to the limit as h approaches 0 of 2x plus 2 plus h. Plugging in 0 for h gets rid of my limit and leaves me with 2x plus 2. 2x plus 2 in this case represents f prime of x in general. It wants me to find f prime of x at -3, 4. So f prime of -3 is 2 times -3 plus 2, or -4. So again, this represents f prime of x. F prime of a number is when you plug the x value into that function. Okay, we want to do the same thing for a different function, but now we want to use the alternative form of the derivative. So that says that the limit as x approaches a. So in this case, my a value is 1 of f of x. So it's the original function, x squared minus 3x minus f of 1 all over x minus 1, because it's f of x minus f of a all over x minus a, where in this case our a value is the x equals, which is 1. So what this limit is finding is f prime of 1. That's what this answer is going to represent. It is representing the derivative of that function at x equals 1. One squared is 1. 1 minus 3 is negative 2. But a minus 2 turns to a positive 2. So you get x squared minus 3x plus 2 all over x minus 1. And that's the same as the limit as x approaches 1 of x minus 2, x minus 1 all over x minus 1. So I can see that I have removable discontinuity at x equals 1. So we can remove the x minus 1. So you get the limit as x approaches 1 of x minus 2, which means this is 1 minus 2, or negative 1. So what that means is that, again, f prime of 1 equals negative 1. And kind of creating that connection to what we've been talking about. If the derivative is equal to negative 1, then that means that the derivative is negative. If the derivative is negative, that means that f of 1 is decreasing. So a negative derivative tells me that the original is decreasing. So if I were to go about graphing this, the original function would be decreasing at that point. Okay, if y equals 1 over x plus 3, find dy dx. So dy dx is just another way of saying find the derivative. So we're going to say dy dx equals the limit as h approaches 0 of 1 over x plus h minus f of x all over h. I need an LCM. So in this case, that's x plus h plus 3 times x plus 3. So we're going to multiply both our fractions by that. So we have the limit as h approaches 0 of x plus 3 now, minus x plus h plus 3, all over that least common multiple of x plus h plus 3 times x plus 3. To get rid of the fraction in a fraction, we multiply by the reciprocal of the denominator. So that brings the 1 plus h, or 1 over h up. And then we're going to simplify. X minus x, 3 minus 3. So that leaves me with the limit as h approaches 0 of negative h all over x plus h plus 3, x plus 3 times h. So I can cancel the h on top and bottom. So I have negative 1 over x plus h plus 3, x plus 3. I can plug in 0 for h. And I get negative 1 over x plus 3, x plus 3. Instead of foiling that, those are the same term twice. So we could say it's negative 1 over x plus 3 squared. There's no benefit to foiling that base. And again, that negative 1 over x plus 3 squared represents the derivative of the original. Represents the derivative of the original. Okay, find d dx of 3x squared minus 5. So again, the same idea is happening here. It is asking you to find the derivative of 3x squared minus 5. So you are going to do that. So we plug in x plus h, multiply it out. Distribute. Clean it up. So you get 6x plus 3h, plug in your 0. And we get 6x. And again, that 6x represents the derivative of that original function. And the derivative represents the slope of the tangent. Okay? Find Find the equation of the tangent line to the graph of f of x at x squared plus 1 for the point 1, 2. So again, same idea. You can use any variation. You could use the limit as h approaches 0 of x plus h squared plus 1 minus x squared minus 1 all over h, and then plug in 1 at the end. You could do the limit as h approaches 0 and you could actually plug in 1. So you could do 1 plus h squared plus 1 minus 1 squared plus 1 all over h. So again, this would give you f prime of x in general. This would give you f prime of 1. And that's actually equal to the limit as x approaches 1 of x squared plus 1 minus 1 squared plus 1 all over x minus 1. So this is the general f prime of x. The second side represents f prime of 1 using the definition of the derivative and showing the alternate form of the derivative. So I'm going to do this variation right here because I feel like we haven't done the derivative at a point in a while. So f prime of 1 equals the limit as h approaches 0, and you get 1 squared plus 2h plus h squared plus 1 minus 1 squared minus 1 all over h. So all the 1's cancel each other. You get the limit as h approaches 0. Factor out an h, and you get 2 plus h all over h. So your h's cancel. And I get that as the limit as h approaches 0 of 2 plus h equals 2. So again, what that means is that the slope of the tangent at x equals 1 is 2. So the equation of the tangent line is y minus 2 equals 2, x minus 1, or y equals 2x minus 2 plus 2, or y equals 2x. So that's the equation of the tangent line at 1, 2. That's only representative of the tangent line at that particular point. The tangent line will change for any different point on x. That only represents the tangent line at that point. The tangent line would change for different points on x. Okay, and then we have a graphical investigation because the second part of your review is, can you sketch the graph given the graph? So this says, on what intervals is the slope of the tangent positive? So we need to know, when is the slope of the tangent line positive? Well, if this is the graph of f of x, the tangent line slope is positive when f of x is increasing. So f of x is increasing from a to b. F of x is increasing from c to e and g to positive infinity. So the tangent line will have a positive slope on those three intervals. Notice how I used parentheses. The tangent line is not positive, therefore I cannot bracket it at B, C, E, or G. The tangent line is not positive or negative at B, C, E, or G. On what intervals is the slope of the tangent line negative? The slope of the tangent line will be negative when the graph is decreasing. So that would be B to C and E to G. At what values of x is the slope of the tangent line 0? The tangent line is 0 at the extremas. The extremas are the mins and maxes of f of x. So the tangent line will be 0 at the extremas, or the mins or maxes of f of x. So in this case, that would be B, C, E, and G. And it's x values, so it's like x equal a number. It is not an interval. And again, what can you say about the graph when the tangent line had a positive slope? So I kind of answered that in the beginning. We can say that the graph of f of x, and again, we like kind of sentences that are concise. You need to label what you're discussing. Is increasing when the tangent line has a positive slope. And then conversely, what can you say if it has a negative slope? Well, now the difference is that the graph of f of x is not increasing, but rather decreasing when the tangent line has a negative slope. So the thought process is the same. What's changing is the values of the slope and the direction of the graph. If I were to sketch the derivative of this graph, So if we're going to sketch it, I'm going to put f prime of x on that graph in red. Everywhere I had an extrema, we said the graph was 0. So that's at B, C, E, and G. So the derivative will be at 0 at B, C, E, and G. We said it was a positive slope. So if it's a positive slope, that means it's above the x-axis. So it'll be above the x-axis from B and on. It'll be below from B to C, above from C to E, below from E to G, and above from G on. Now, on our chart the other day, we talked a little bit about concavity. When f of x is concave up, so concave up is when it's like kind of open to the sky. So in black, when f of x is concave up, then f prime of x is increasing. If f of x is concave down, then f prime of x is decreasing. So that tells me even a little bit more. That tells me that where this graph is yellow, my derivative has to be decreasing. So it's positive above, but decreasing. Oops, I wanted that to be red. So it's positively decreasing till B. It decreases till like we get to the black change in here. And now it's negatively increasing again until I get to that black and yellow change. Then it goes back to decreasing until we get to that black and yellow change. And then it goes to increasing. So again, it's not perfect. I don't actually know the slopes, but this is a rough idea of what that graph of the derivative would look like compared to the graph of the original. You'll notice the original had 4 extrema. The derivative has 3. Every time you take the derivative, you should lose an extrema. Every time you take a derivative, you should lose an extrema or sketch the derivative.